This is my oscilloscope. It's an OWON or AWON VDS1022i. It's a USB oscilloscope, and to be honest, well, I've always been a little embarrassed by it. Other people on YouTube and other people I know have these big oscilloscopes with lots of buttons and dials and a screen, and they can just set it up on their bench. They don't have to worry about hooking it up to a laptop or other device to actually see what's going on the oscilloscope. But today, I'm going to change all that. That's right, today, I'm going to pimp my oscilloscope. So this oscilloscope you can buy online. It's fairly cheap, I'd say around $100. It does have an isolated USB connection so that you don't have to worry about problems with the signal because it has a common ground. It actually has an isolated ground on it, which is nice. And it's always performed pretty well for me. It has 2 channels. But the downside of this is that you do need to hook it up to your computer or a laptop. And that becomes a pain when I'm working out here in the shack on something. I have a fairly large laptop, and even that gets in the way sometimes when I want to use this thing. So I just don't use it as much as I probably should or could. And also, I've always thought that the performance of this thing was a little bit lackluster and maybe wasn't quite as good as some of the other USB oscilloscopes. But not too long ago, Adrian Black on his channel did a review of this particular oscilloscope, USB oscilloscope, as one of the cheap oscilloscope options, and came away really liking it. In fact, as he walked through some of the options, he kind of taught me a thing or two about the performance. And, you know, I started to actually feel pretty good about my decision here to purchase this and actually use it on the channel. But it still is rather clunky to haul out a laptop or a computer to be able to use this thing. So today, I'm going to go through some upgrades where hopefully I can just sit this thing on the desk and have it be a little bit more like a modern oscilloscope, maybe with a display or a touch screen. Maybe it can sit in its own case even. And yeah, so I'm just really excited to see what I can do with this thing and hopefully be using it a lot more on the channel. So for the computer component, I'm going to be using this. It is what is this? I had to make sure which version it was. This is an Orange Pi 3. Now, about 10 years ago, I started getting really interested in the Raspberry Pi. And as part of that, I started ordering all of these clone boards from different places. There's Orange Pi, there's Banana Pi, there's all kinds of different ones. And the Orange Pi boards have always been pretty good for me. And in case you're wondering, here are the specs. It's got an H6 quad-core, 64-bit, 1.8 gigahertz ARM Cortex A53. It's got all sorts of other things. It's got a Mali GPU. It has fast memory types for DDR3 and such. And it's got built-in Wi-Fi and Bluetooth. It's got an onboard networking port. It's got USB 3, HDMI 2, blah, 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 blah. So it's actually a pretty capable board. Anyway, I got really interested in these boards, and I even wrote a book on the Raspberry Pi itself called Linux for Makers. So if you've ever been interested in the internals of Linux, kind of some basic things about how Linux works, how the directory structures are laid out, and some projects that you can do along the way as you're learning about Linux on the Raspberry Pi, you can find that book at Amazon or better booksellers nationwide, I guess. Is that what you say? I don't know. Sounds like something somebody would say. That board is, however, a little long in the tooth. It's been around for a while. Unlike this, their latest version, this is an Orange Pi 5 Plus. So this has the Rockchip 3588 or whatever it is. Pretty powerful. It's got NVMe support for like PCI Gen 3 or 4 or something. It's a pretty cool board, and it compares very well with the Raspberry Pi 4. In fact, the Raspberry Pi 5, I guess, is out now. It beats the Raspberry Pi 5 on most tests, I think almost all of them. So very powerful board. It's got HDMI in and out. So I haven't quite figured out what I'm going to do with this board yet, but I'm still buying these boards because they're just fascinating what you can get for a very low cost and a very small form factor. Great to use in projects. Now, you might be asking yourself, why are you using this board instead of the Raspberry Pi? Well, in my tests on the Raspberry Pi, when I was loading the software for the oscilloscope, I found that for whatever reason, I think it has mostly to do with the software version that I was running on the Raspberry Pi. The software for the oscilloscope back there actually performed very poorly. It was very slow, very sluggish, and I had this one sitting around and I already had an older version of Ubuntu loaded on it, and so I tested with this and it ran really well. So I thought, well, I've just got this one sitting around. It's long in the tooth. It's not as powerful as the Raspberry Pi 4 that I was testing with. And so the software works really well with this thing. So why not just use this? Because otherwise it's just going to be hanging on my board. I've got this cork board in back of my computer monitors, and it has a lot of these boards that I've used over the years. And if I find a use for them, like I did with this one, take them down off the board and they're ready to go. Okay, the other thing we're going to need is a display. And for that, I've chosen this display here. This is a 10-inch touchscreen display, and it's not just the display itself. It actually has some features that's going to make this build a lot easier to implement. Number one, on the back of this board, it has speakers built in. Not a huge feature, but I do like that in this case because I don't want to have to hook up discrete speakers. I want this to be an all-in-one package when I'm done with it. So that was very important. It has HDMI input right there, which is really nice. This was actually built for, I think, a Raspberry Pi to kind of plug in, and then you use this little adapter to go in the HDMI, or it's built for one of the boards. I can't remember exactly which one. But yeah, it's got a little speaker dial over here. It's got the touchscreen USB port is right here, and it's got this little cutout, which is really nice. So you can actually plug your cord in without it, putting a lot of stress on that connector right there. And it's also got some other display ports here and touch ports also on the side if you want that. So it's a nice little option. And then it's got power here on the side as well. So you can plug that in. So all in all, this is a really nice little display. I can't remember how much I paid for it, but I'll be putting a link to all these things in the description below and maybe overlay the screen here with some links or pictures or prices because it's been a while since I got this and I don't remember. And of course, this thing does come with a protective cover, a protective plastic sheet. Trying to protect our electronics from scratches, etc. So yeah, you know what we're going to have to do. Cue the music. No more protection for this thing. And then now it's really, really reflective. Ooh, hey everybody. Now this display also came with these little plastic stands here. And the way these work is there's a hole in the back here and you screw that in like that. And then this thing can sit at an angle on your desk so you can actually see it and use it, which is cool. But that's another reason why I got this particular display is it has these little mounting screws in each of the four corners. The reason that's important is because I want to put this in a case. So I opened up my CAD program and designed this. This is the first version of this that came off the printer. It still has the supports here for this big opening, but let's see if we can take those out really quick. There we go. And there's the case I designed. Again, this is the first gen. I'll have to see if this works. Prints almost never come out, especially the ones that you design yourself, almost never come out the first time. And the idea here is that you would be able to put the oscilloscope in there like that somehow. That doesn't fit, but I think it's because these things are still on here. But that would go in like that, and then that would go in between there, and then the display would go on top. And with everything hooked up together, I should be able to stand this up on something like that on the table here, and then I would have a standalone oscilloscope with touchscreen and everything else, just like those big YouTubers have that I watch when they buy their expensive gear. So inexpensive and hopefully usable. We'll see. Let's start to put this thing together and see how it goes. Now, if you're like me and you love putting together projects like this, then you're going to love today's sponsor, PCBWay. PCBWay offers inexpensive PCB manufacturing and a whole lot more. Need assembly services? No problem. They can do front side, back side, through-hole components, you name it. They also offer 3D printing, CNC milling, and more. So check out PCBWay for your next project, and I thank them for their support of the Retro Hack Shack. I did have to order some tiny cables, the tiny tools, if you remember that Seinfeld episode, but I did have to order some small cables to kind of fit, hopefully, in the back of the enclosure here so the cables aren't sticking out everywhere. And one interesting thing is that I ordered this USB-A to USB-A cable. And the reason I did that was because, unfortunately, I think this is probably kind of a poor design, but the oscilloscope that I have, the USB connection on it, instead of using USB, what is it? I think it's B, the big square one. They used USB-A, and they have a cable which is USB-A to USB-A. So I don't like that because it's easy to mess this up, and you could perhaps ruin something when you're doing USB-A to USB-A. So I don't like that, but that's what it is. So I've got to have this special cable here. Otherwise, it's all pretty much standard cables. So let's go ahead and assemble it and see what it looks like. I will need to remove these plastic covers here that also serve as kind of a little stand so that this will hopefully fit. Yes, now it fits in the case I designed. Yay. Now, in order to keep the oscilloscope secured to the back of the case and keep it from, sliding around and rattling around and all that kind of stuff, I'm going to be using this. This is 3M dual lock tape. And what it is essentially is kind of like a Velcro or hook and loop, but it's very, very rigid. I don't know if you can see that. Maybe if I do it this way, you'll be able to see, but it's very, very rigid hook and loop system, hard plastic, and it actually works quite nicely to hold things very securely, but then allow you to get them off again if you need to remove it. So very much like Velcro, but even sturdier than Velcro, and the adhesive that 3M used on this stuff holds really, really well. It doesn't come off very easily. And I designed a little extra room in the case, at least a 1/4 inch, I think, in between where the back of this oscilloscope is going to be, the metal part of the oscilloscope here, and the Orange Pi that I'm using as the computer. So there should be enough of a gap there that I can use this tape and not have anything really touching once it's all put together. So I've taken 2 pieces of the dual lock on each side. I've put them together and then taken the backing off of each side. I put one side down. This is now sticky and ready to go. So now I can put in my oscilloscope the way I want and hopefully get this lined up right. I do want to make sure that I have access to the BNC connectors where you hook up the probes. I kind of want it towards the opening over here. Nope, I'm going to have to move. This one is too far outside. Luckily, I didn't press this down too much, so I'm going to have to move that one in a bit. Now I'll just press it down and make sure it's making good contact. That looks pretty good. Can I still hook up a probe to this, though? Yeah, I can, no problem. All right, well, it looks like it's going to fit. This is my first fitting. Like I said, the first time is never a charm usually, but I've been doing this for a while, so... oh, yep, there's one side. Is it actually going to fit on the first time? Oh, it's so close. Oh, and I think I see the problem. I think the thing that's actually getting in the way is this stereo jack here, this external audio jack. So I think that's what I need to cut the hole for. And something else I didn't account for. It's this audio volume control here. So that, again, I'm going to have to cut a little cutout for. But luckily it's right there at the top of the case, so it's no problem. I can just snip that out. And the perfect tool to make a little cutout like this when it's on the edge of the case is this. It's a little nibbler. And the way that works is... see that little end up there? When you squeeze down on the handles, it actually just cuts off a little bit at a time. And that works really well. Let's see if I can do this on camera. Line this up with where I think this needs to go, and then squeeze. There we go. And you can see it takes just a little chunk out of the plastic there. And I'll just make several of those until I have the right size for the stuff that's getting in the way here. Well, I'm not going to lie, that was a tight fit for sure, but my calculations, I think, were pretty good. Maybe I was off, half a millimeter, if that. But what I had to do was I had to use some drill bits and just ream out those holes, because sometimes when you 3D print holes like this, it either expands or you get a little string in there or something. So I used the drill bits just to ream those out, make sure they were nice and smooth and big enough. And yeah, after that, with the holes cut for the things that were in the way, now this thing fit together perfectly. So I'm a one-hit wonder, apparently. No, one-hit wonder? That's not the right analogy. First time winner? I don't know. But the 3D printed case actually fits this fine, and I will put a link to this. I'll put it on Thingiverse or something, and I'll put it down below along with the other parts if you happen to have one of these oscilloscopes and you want to build this project. One of the things I was worried about when I was designing the case was I wanted it to be sturdy enough so that I could tap on the screen without it falling over. And it takes quite a bit of force. It wants to come back down into this position, and it takes quite a bit of force to really push it. But just tapping on it like you would tap on your phone or something like that actually works really well. And of course, now I've got fingerprints all over it from getting the display fitted into the case. But yeah, I've got an oscilloscope probe hooked up. This should boot right up into Ubuntu, the Orange Pi version of Ubuntu that's a little bit older, and that's good because for whatever reason, the older Linux kernel seems to work with this software better, which is why I went this route with the Orange Pi instead of a Raspberry Pi 4. Moment of truth, with this thing being so reflective, I hope I have the manual focus set right. Now, I am using, the power supply that I'm using is way overkill. I think it's 10 amps. But what I found, the other nice thing about this Orange Pi is it passes the power through the USB to the board. So you can actually power this thing through the USB connections, which normally isn't good. But in my case, it actually is good. You normally don't want that because you could short circuit something if you were to power something in through those USB plugs inadvertently. So let's go ahead and plug it in and see if it's working. Okay, I heard a little buzz, buzz, buzz from the speakers. Looking good. No signal, which is normal, should be normal. This is a nice, bright display as well. Okay, booting Linux. That looks good. Let me zoom in a little closer here so we can get the big reveal. There it is. Orange Pi booting up. A little closer. Hopefully that's still in focus, and there we go. There we go, it's working. So for whatever reason, I'm getting this startup thing. I don't want to see that. Don't show again. Now I did hook up a mouse to this initially, just in case the touchscreen wasn't working or something, but it appears to be working fine. So now I've got an oscilloscope in the box, full screen display, no buttons, everything's touch control. Some people like that, some people may not, but for me, this is going to be perfect. It's big enough to see. It's a 10-inch display. Let's see, 8 inches. Yeah, 10-inch display. Totally big enough to see, but it's not too big that I can't put it next to a project that I'm working on and still see what's going on. So yeah, I've got my probe hooked up. Let's just connect this to the square wave tests up here. I think it's like a, I don't know, 5-volt square wave or something like that. Plug that in. Uh-oh. Getting static. Why am I getting static? There's 2 ports here actually on this test. There's one on one side and one on the other. There we go. Hey, look at that. Nice. So that's 8 volts. So yeah, 5-volt square wave. Got some static. Oh, because I don't have the ground connected to anything. So let's connect this to one of the empty things. There we go. Perfect. Now I've got it connected to the ground on one of the ports that I'm not using there at the moment. So it's getting the ground reference. So now we've got eliminated that static and we're getting the nice solid square wave. Look at that. Awesome. So like I said, for things that are too hard to touch, I've got a mouse over here. But let's just use the old magic finger and see if we can change some stuff around and see what's going on here. So let's change the Can we zoom in on this or just make it different? Oh, yeah, that's way out. No, that's too far out. Let's zoom in. Can I, yep, do the scroll bar? Looks like it. No. Oh yeah, I just didn't have it there. So now we can choose something a little bit smaller. 100 microseconds. Yep, look at that. Fine. I think this is going to take a little getting used to, but 200 nanoseconds? Oh, that's too close. That's too close. Can't see anything. 500 microseconds. There we go. That looks nice. Yeah, so the touchscreen is working. I think another thing that might be difficult to do with my finger is change the trigger. Normally you can slide that up. Oh yeah, I did it. Yeah, now it's right on the edge, so it's sometimes triggering, sometimes not. Let's move that up a little bit more. Can I get it? Yep. There, now it's not on trigger mode. The trigger is above the wave, but we're still seeing it because it's so regular. Let me pull that back down. There we go. Now it's triggered again. Wow, really cool. So yeah, this is working great. I could probably pop in here, change that to 5 volts. Yep, I heard the relay click. And now we've got 5 volts per division. So that's one division there. And then of course it goes up all the way up to, in this case, 20 volts. Nice. Change it back down to 2 volts per division. Wow, really cool. So yeah, this will be great. This will be so much better than having my big laptop out or a desktop to have to display this on. So this is a perfect solution for me. Now, this might not be, if you don't already have one of these oscilloscopes, maybe it's not your cup of tea. Maybe you would want to try to do something else. There are some cheap oscilloscopes that are out now. That are like less than $500 for like a 2-channel oscilloscope, which has really nice display and nice storage, amount of storage and things like that for you to use. So probably if I were doing this from scratch, I would probably go that route, given that, you know, the oscilloscope I think was a little less than $100 or something like that when I bought it. I had to have a 3D printer to print this out. The display and all that stuff, I can't remember how much it cost. I'll put the total dollar amount for all of these things, including the cables, on the screen so that you can see. But probably by the time you get all of this put together, it's going to be probably the same amount as buying that entry-level oscilloscope. So yeah, if you have to start from scratch and you don't have any of this, probably that's the best way to go. But I already had the Orange Pi, I already had the oscilloscope, I already had most of the stuff sitting around except for the display and a few cables. So I would say this is a winner-winner chicken dinner, to coin a phrase from Dave Jones. Okay, well now let's actually test this on a real system, on a Commodore 64. So I've got this hooked up and, oh, yeah, when you touch that, it does crazy things when you touch the probe to your skin. But let's just go ahead and look at some typical tests that you might do to a Commodore 64 and see what's going on. Now, this is the one, you'll notice I've got some mods here. If you look back on my channel, way back, you'll know that this is the mod I did for RGB to HDMI. This is the old version. The new version, I just released a video a few weeks ago, or maybe a few months ago now, where I showed a new, easier way to mod the C64 for HDMI out. But that's what all of this stuff is here. So let's just try some troubleshooting techniques. I want to get my 6510 pin out here so we can check the reset line, pin 40. So go ahead and put that on pin 40. There we go. And let's turn it on. And what we should see on the reset line is that it stays low for about half a second or so, and then it goes high. So let's see what happens. Ready? Stays low, goes high. So yeah, the system is not being held in reset, and this is a good working system, so that much should be true. We can also check the clock, maybe. Let's see, I think that's pin 1 here. So yeah, that's looking like a clock, but let's go ahead, because I can't see this. This is a, whoops. This will be a good test of whether this will work or not. So let's see, I want to get my view down to something more reasonable. Oh, that's too close. Let's go with 1 microsecond. There we go. And it shows me the frequency right there, 1 megahertz or thereabouts. So the signal's a little bit noisy. I am using a super long ground cable though, which is a no-no with oscilloscopes, I know, but it's just easier. And for this kind of troubleshooting, really with Commodore 64s, it doesn't matter that much. You can kind of tell what's going on. But yeah, there's either some bad filtering going on, or because of the super long ground lead that I've got here, it's causing some noise here, but that's okay. Now let's check one of the analog pins. I think all of these should be analog pins down here, and we should see, yeah, activity looks normal, no problem. Looks really good, actually. And we can even check the data lines, which are on the other side. Let's see what's going on the data lines, if anything. Yep, got activity on the data lines as well. So yeah, if I didn't know any better, and I don't because this isn't connected, I would say this is a completely working C64, at least from the CPU standpoint. Oh, there's a problem. Will that come back? Yeah, it did come back. I've noticed that a couple of times that for whatever reason, I don't know if it's the maybe not enough power getting to the Orange Pi or what, but every once in a while this display will blank out and then it will come back like in a second. Not sure what's going on there. Hopefully there's not some sort of bad ground connection or shorting going on. I don't think there is. But if that's all that's wrong with this thing, I can live with it. Maybe I'll investigate that further later. Let's see if we can take a look at some of the memory maybe. See what's going on there. Oh yeah, some activity on the memory, just like you would expect. So yeah, this is going to work out really well. I really like this setup. I like the fact that I can move this around. I can put it flat if I want, or I can lay it up. I can click on it with my finger, or I can use the mouse. I could even split the HDMI out if I wanted to and get a capture if I wanted to go that route. So yeah, I'm really liking the setup. I'm glad I pimped my oscilloscope and got it up and working. So this is great. If you want to see more videos like this, more repair videos or more hacking videos, more mods, I will put a link to a video up in the corner that you can click on, and I'll see you over there in the next video. Thanks for watching. Bye.
End of line.